This video is going to be on intermolecular forces, and when we take a look at what intermolecular forces means, inter means between, molecular obviously means molecules, and these have to do with forces that are between molecules. So they're not forces that are in molecules. Those are called covalent bonds. These are forces that are between the molecules. So we can see here when we take a look at intermolecular forces, this right here is the force of attraction from one molecule to the next. Now, intramolecular forces are, again, covalent bonds. These are very strong. Intermolecular forces, or what's defined here as forces of attraction between molecules, is about 1% as strong as covalent bonds. They're very, very weak. As a matter of fact, as I mentioned here, they're quite weak compared to covalent bonds. So they're about 1% as strong. So about 1/100th the strength. Okay, so these are forces of attraction between molecules. So as we know, let's just sum this up. The strongest forces of attraction, or the strongest chemical bonds, are covalent bonds, and then we have ionic bonds, and then finally we have these intermolecular forces. Okay, so this is what we're going to concentrate on right now. So these are the weak forces of attraction between molecules. We can rank them. There is actually hydrogen bonding, which is a type of dipole-dipole force, but it's a special dipole-dipole force, which we classify as on its own. Then we have just regular old generic dipole-dipole forces, and finally London dispersion forces. Okay, so those are the weakest. Strongest is hydrogen bonding, dipole-dipole, then London dispersion. So let's talk about these three things. Okay, a hydrogen bond is very it's a little bit complex to talk about, but what it is it's a hydrogen atom that is bonded to a highly electronegative atom, which has to be N, O, or F, and that's attracted to an unshared pair of electrons on an electronegative atom to a nearby molecule. So this always occurs between highly polar molecules. So let me tell you what it is. I have a hydrogen attached to or covalently bonded to a fluorine, and here is a nearby HF molecule. And what happens is this hydrogen bond, since fluorine is so electronegative, this fluorine right here takes the electrons that hydrogen has and sucks it towards it because, again, the tremendous electronegativity difference. So all the electrons seem to be around the fluorine. All the electrons seem to be around the fluorine. Well, if I take away hydrogen's only electron, all it has left is one single proton. So all it has is a proton right here in its nucleus. So all I got is a proton right here in its nucleus. So therefore, this side is very slightly electronegative, and this, slightly negative, and this side is quite slightly positive. Therefore, it forms an attraction between this proton here to the electrons here, and that is my hydrogen bond. Okay, so the hydrogen bond occurs from the hydrogen to the electrons on a nearby molecule. Then those electrons are valence electrons that are attached to a highly electronegative atom, such as fluorine. Okay, it could be oxygen or nitrogen. Okay, so that's a hydrogen bond, the strongest of the dipole-dipole forces. Next, we have just regular old generic dipole-dipole forces, which don't happen to be hydrogen bonds. And this is a force of attraction between polar molecules. So that's what you got to understand here, the force of attraction between polar molecules. So hydrogen bonding is a special type of dipole-dipole force of attraction between polar molecules. These are very or highly polar molecules, but there it is, as I mentioned here. And dipole-dipole forces of attraction are forces of attraction between polar molecules. So if they're polar, they are dipole-dipole no matter what, okay? The last type, which is the weakest, is called London dispersion forces. These are weak intermolecular forces that occur between two nonpolar molecules. Okay, so this is the key here. If you have a nonpolar molecule, you have they are subject to London dispersion forces. Okay, now this is also called an instantaneous dipole because all of a sudden the electrons, let's say on our chlorine-chlorine molecule here, for some reason, it could be some force of attraction, some magnetic field, all of a sudden causes the electrons to all bunch to one side. So here they are on one side of the molecule, and this side only has a couple of these electrons. So just for an instant, called an instantaneous dipole. In an instant, a fraction of a second, this side is slightly negative and this side is slightly positive, so therefore it is weakly attracted to another molecule that would do the same thing. But again, it's only for an instant, so once that thing happens, once these molecules have this instantaneous dipole, the electrons disperse back to where they should be and everything's fine and good. So these are very weak forces of attraction. So we see this in H2, Br2, O2, N2, Cl2, I2, and F2. Okay, London dispersion forces, especially in those. Make sure you know all of those. Okay? Let's see, is there anything else? Here's a video to check out the sum of all the bonds. I'll leave it up here for a second, or you can pause the video if you want to check this out. But this video is a pretty good video that sums up all these bonds. Okay? If you have any questions, let me know.